This is the patient with ischemic cardiomyopathy implanted with a single lead ICD. We could find in the memory of the device a second episode of VF, and this one required 2 maximal electrical shocks. Initially, you can see a normal rhythm and then an acceleration in the VF zone, initial detection of a VF episode, the first shock. It does not seem to be efficient, and then there's probably a redetection of the VF. There is a change in the rate at the level of the ventricle, but the second shock is delivered. In this tracing, we will focus on what happens at the end of the charge, at the time of the confirmation before delivering the first shock, and then the second one. Now, if you look at the EGM, you can see a very fast, polymorphic, and disorganized arrhythmia after 30 cycles, initial detection of an episode of ventricular fibrillation. Then starts the charge of the capacitors, and at the end of the charge you can see the marker CE, and then there is a confirmation. In the single lead ICD, you will look at the 5 cycles that follow the end of the charge, and the shock will be delivered like here on the second tachyarrhythmic events. So to deliver the shock, you need to have at least 2 tachyarrhythmic events on the next 5 cycles. When the shock has been delivered, there is a blanking period of 520 milliseconds, then starts the redetection process. You can see here that the shock has been inefficient, and then there is a redetection of the same episode of VF after 12 out of 16 cycles classified as VF. Then the second charge of the capacitor will start. What is important to know is at this time, if there is a redetection of an episode of ventricular fibrillation, then the second shock is committed. It means that whatever happens now, the shock will be delivered at the end of the charge. This is a quite unusual tracing, since there is a spontaneous reduction of the ventricular fibrillation after the redetection of the episode. So at the end of the charge, the shock is committed and will be delivered, even if there is a reduction of the arrhythmia. Because at this time, the risk of undersensing of a real ventricular fibrillation is much higher than a spontaneous reduction like in this example. So once the capacitors have been charged to the programmed energy, the device starts the synchronization process with a 900 milliseconds delivery timer. If, like in this example, during this 900 milliseconds there is a spontaneous activation, then the shock will be delivered synchronously with the R wave. If after 900 milliseconds there is no sensing of a ventricular event, the shock will be delivered asynchronously at the end of this 900 milliseconds timer.